Hey, we are solving limits analytically. We have the limit of x squared plus 1 over x minus 1 as x approaches 1, and I'm claiming that this limit does not exist. Now, just to mention here on the notation, as you can see, this is not just an equal sign, but it's a colon plus an equal sign. Now, remember that our limit is always equal to a real number, and obviously this is not a real number. But I'm just saying that this limit is defined as does not exist. And we know that because we do the direct substitution, plugging 1 directly in for x, and we get 2 in the numerator and 0 in the denominator. So if we get a picture that looks like this, where we get 0 in the denominator and a number in the numerator other than 0, we can say that this limit does not exist. Let's look at another possibility. Okay, in this one here we have the limit of the square root of x minus 9 over x. I'm claiming that it's equal to 0. We do the direct substitution, plugging 9 directly in. As you can see, we get 0 in the numerator, and then a number other than 0 in the denominator. And when you get this, it's equal to 0. So this was another possibility dealing with zeros. Let's look at all three of the possibilities now that we've talked about. So the three possibilities are getting 0 over 0, 0 over a number other than 0, and some number that's other than 0 over 0. So we said in this particular case here that this is actually equal to 0. This does not exist, it's undefined. And then when we get this case where we get 0 over 0, we need to manipulate our function so that we get a new function. And then do the direct substitution and take the limit. Or I should say, we're taking the limit and then do the direct substitution. So these are the three possibilities that we may encounter. And of course, I'll be working in a lot of my problems with this case here where you get 0 over 0.